We will now discuss the solution to problem 5-19 on page 219 of the textbook. Problem 519 deals with a company named Shirts Unlimited, which operates a chain of shirt stores that carry many styles of shirts that are all sold at the same price. The company, in trying to encourage their sales personnel to be aggressive in their sales efforts, has paid a substantial sales commission on each shirt sold, as well as a salary is received by each of the sales persons. The following worksheet on page 219 gives you a breakdown of the selling price, the variable cost, the total variable expenses, the fixed expenses, as well as the total fixed expenses. And the company has asked you as a member of their planning group to assist in some basic analysis of the stores and their company policies. Part 1 asks to calculate the break-even point in dollar sales and in unit sales for store 36. So for store 36, which is the store we have the information for, in order to break even, using the formula method, we take fixed expenses divided by the unit contribution margin. Fixed expenses in this problem are $300,000. The unit contribution margin is $15 per shirt. The $40 sales price less the variable expenses of $25 per shirt. So you take the $300,000 divided by $15 per shirt. You need 20,000 shirts to be sold in order to break even for store number 36. The dollar sales to break even is simply the fixed cost divided by the contribution margin ratio. The contribution margin ratio in this particular problem would be the $25 of, the $15 of contribution margin divided by the $40 sales price, which equals 0.375 or 37.5%. When you divide the $300,000 of fixed expenses by the 0.375 contribution margin ratio, you've determined that you need $800,000 in dollar sales in order to break even. You could have gotten there a little quicker. After you'd calculated unit sales to break even, you could have taken the 20,000 shirts that it takes to break even and multiplied it by the $40 sales price per shirt. You would have come up with the same $800,000. Okay, part 2 deals with a graph. They ask you to prepare a CVP graph. That can be reviewed by you in the solution manual. I'm not particularly hung up on that, and you don't need to worry about that too much. Part number 3 deals with, they change up the scenario a little bit. They just ask a question: if 19,000 shirts are sold in a year, what would be store 36 net operating income or loss? You should realize right away that, having calculated the break-even point to be 20,000 shirts, that if you were told you're only going to sell 19,000 shirts, you should see right away that we're going to realize a loss. We're selling less than the break-even point. The question is, how much of a loss? Now, you could walk through a long-form solution by doing a contribution margin income statement and calculating sales revenue at 19,000 shirts to be $760,000, variable cost to be $475,000, which is simply the 19,000 shirts times $25 per shirt, and doing the math and coming up with contribution margin of sales less variable expenses of $285,000. Then subtracting your fixed cost of $300,000 to come up with a net operating loss of $15,000. Now, you could also have taken a shortcut method and said to yourself, you know, break-even sales are 20,000 shirts. We actually only sold 19,000 shirts. We therefore were short of our break-even point by 1,000 shirts. And understanding contribution margin, you realize that you just lost 1,000 shirt sales. You really lost $15 per shirt. Don't need to go through all the math that I just did. 1,000 shirts times $15 per shirt equals a $15,000 loss. Moving on to part 4 of the problem. Part 4, you were asked, the company is considering paying the store manager of store 36 an incentive commission of $3 per shirt, in addition to the salesperson's commission. If this change is made, what will be the new break-even point in dollar sales and in unit sales? With a new incentive commission of $3 per shirt, presently, or in the original information, contribution margin per shirt was $15. The $40 selling price less the $25 variable cost. This additional incentive commission to the manager of $3 per shirt will increase variable cost by $3 or raise them to $28 per shirt, and that subsequently reduce the contribution margin per shirt to $12 per shirt. Therefore, we can then go through our break-even formula of fixed expenses divided by the unit contribution margin, in this case $300,000 divided by $12 per shirt, to now see that we will have to sell 25,000 shirts to break even, given this new incentive commission. When asked what the dollar sales to reach that break-even point are, we would take the $300,000 of fixed cost divided by the contribution margin ratio of 30%, which is $40 less the $28 variable cost, gives you contribution margin of $12. If you take that $12 contribution margin and divide it by a $40 selling price, you come up with 30%. If you take the fixed cost of $300,000 divided by 30%, you realize that you need $1 million of sales revenue to break even. You could have taken the 25,000 shirts that you sold to reach the break-even point, multiplied that by $40 a shirt to also realize that you would need $1 million in sales revenue to break even. Moving to part 5, where they send us back to the original data again, and they say as an alternative to number 4 above, the company is considering paying the store manager $3 commission on each shirt sold in excess of the break-even point. If this change is made, what will be the store's net operating income or loss if 23,500 shirts are sold in a year? This approach to solve this problem would be your actual sales are 23,500 shirts. Going back to the original data, the number of shirts to be sold to break even are 20,000 shirts. Therefore, at 23,500, we would have 3,500 shirts sold in excess of the break-even point. Therefore, the store's net operating income would simply be those 3,500 shirts multiplied by the additional $12 of contribution margin realized for each one of those shirts, or $42,000. 3,500 times $12 a shirt, $42,000 of additional profit. That additional contribution margin will fall right to the bottom line and improve our profits accordingly by $42,000. Now, moving on to part number 6. Part number 6 tells us that, going back to the original data, the company is considering eliminating sales commissions entirely in its stores and increasing fixed salaries by $107,000. They would like to, if this change was made, they'd like to know what the new break-even point in dollar sales and unit sales would be. And then part B, they want to know, would we recommend that change be made? Using the formula method, alright, we could go through and determine that the unit contribution margin would now be $22 per shirt. We would reduce or wipe out that sales commission of $7. Our only variable cost would be the cost of the shirt of $18. Subtracted from the $40 selling price, we have a $22 contribution margin per shirt. Using the equation method, as you can see, you can take the in the solution manual, you could take the $22 times Q minus $407,000. Work your way through to come to 22Q equals $407,000, or $407,000 divided by $22 per shirt, to come to the break-even point of 18,500 shirts. You could have simply divided our new fixed cost of $300,000, which was original, plus the additional $107,000 of fixed cost that you would have by eliminating the sales commissions entirely and putting all salespeople on a fixed salary, which would have added an additional $107,000 of fixed cost. This would certainly lower the break-even point down to 18,500 shirts, and we would only need $740,000 in sales revenue to break even. However, you should recognize that that could be problematic for putting salespeople on a fixed salary, being that their incentive to sell may be reduced a little bit since they're not being paid every time they sell a shirt, and therefore you may have trouble realizing or recognizing the amount of shirts to be sold. You may see a decrease or decline in the units sold as a result of how you're compensating these salespeople. So that does it for problem 5-19.